And oh, here he is.
My camera is like jacking.
That was-
I don't know what's going on.
You're live, so if you want me to take you off, I'll take you off.
What's that?
We're live, so if you want me to take you off, I'll take you off.
No, I'm good. I'm good.
You're good?
Yeah.
All right. Oh, your audio's a little weird.
Everything's a little weird today.
Okay. Yeah, you're coming in with the slight delay, and then your audio is sounding. There's a lot of reverb. Oh, you're gonna throw on the iPods?
Yeah. I'm ready for those.
That
So
might work.
let's see. Fix this.
As we work through these technical difficulties, last week we talked about time dilation, and we also talked about a little bit about entropy. I think we ended up spending more time talking about entropy than anything else. We also had some conversations about quantum entanglement, just a little bit. We didn't talk a whole lot about it. And today you wanted to have a conversation about quantum tunneling. But I think before we fully kick it off, you went fully silent now. It was weird. Before we fully kick it off, I wanted to see if there was anything from last time that you wanted to clear up, talk about, go over once again, or anything like that.
From last week's episode, nah, we'll leave it at that. I'm kind of excited for this one.
There is a few things that I wanted to kind of clear up, and kind of not fix or not correct, because I am, after all, somebody who's not super well versed in this area. I probably know more than the average human about physics, but I'm still not a physicist. This is not what I do for a living. I'm not a professional. This is not, and I'm using this as kind of a way for me to learn from humans like you, and challenge each other and all that stuff. So one thing that I had mentioned was about Albert Einstein being kind of the father of quantum physics. He was one of them for sure, and then later a critic of the way it was taught. So I wanted to because I was unsure, but yeah, he is one of the fathers of quantum physics, or he's credited as being one of the fathers of quantum physics. The other thing was, I think we mentioned this a little bit about superpositions.
Yep.
And I think in a brief conversation, we had a conversation about quantum entanglement that I just didn't fully understand. And we talked about it more for the computer's sake. I think we spent a lot of time talking about how you can't save data on both sides just because of the superposition. And I guess I just wanted to clear up, and I'm just now kind of fully understanding what people mean by this. Is the idea of the superposition being it's both until it's measured. And I was always under the impression, I don't know why, and silly me, I should have known better, but the observer does not have to be a conscious observer. It could be any observer. It could be any measurement. It could be another proton. It could be another electron. It could be something else that is observing it, that it does not have to be a human observing it. It just needs to be measured. Once it's measured, it kind of, the superposition crumbles, and it's no longer there. It's also, I think, well, we'll talk about it when we talk about quantum entanglement, because we didn't talk about quantum entanglement all that much. There was just a couple things that I wanted to kind of cover and make sure that I didn't get super wrong. I'm okay getting it a little bit wrong, because we're talking about stuff that gets hyper fucking oversimplified. It gets hyper simplified, And I think that's what confuses a lot of humans. They oversimplify, and it's like that makes no sense because of the oversimplification. Anyways, remind humans who you are after I said all that.
Yeah. So I'm Richard Fletcher. That's what I go by on pretty much every social media. Um, I'm an engineer. That's what I do. Started off mechanical engineering, got into electrical engineering, and physics is just kind of a hobby for me. So,
Yeah.
still trying to understand everything, myself. So,
Yeah, for
yeah.
sure. Sweet. Sweet. And I'm none of that. I'm not an engineer. I'm just an amateur that absolutely loves physics, astrophysics really more than anything else, but absolutely love physics, and I always love learning. I'm definitely that weirdo in the family that likes to talk about this stuff, and then everybody else just kind of like, I don't know what the fuck this weirdo's talking about. Also, I use a lot of bad words, so you'll see that as a common thing. I don't even think about it; it just happens, and it's it's not a conscious thing that I do. But at any rate, I hope that these little episodes, podcasts, whatever it is we're calling it, helps other humans that are kind of in our same position where like we don't know everything. We probably are getting it some of it wrong, but at least we want to talk about it and have a conversation about what it is and what it does and how it affects our lives and maybe challenge humans to be better. Um, so hopefully it does that. Today you wanted to talk about some weird stuff.
Weird stuff. Quantum tunneling. Strange phenomena, which, I got to have a little bit of a close up with that at work. Basically, I work in radio frequencies. So to me, quantum tunneling is a little bit different. I know that they're using, uh, solid state uh, drives and microchips and things like that. In the RF world, I look at it as reflections. Um, Whenever a signal is transmitted over a transmission line or a medium, you get some of that signal coming back. But in my world, we measure how much of that signal is actually coming back and how much goes through. The way that quantum tunneling works, though, is a particle moving through a solid mass. Uh, but the way that quantum tunneling kind of works is because it's in a waveform and you don't actually know where that particle is within that wave. So it's like you can't tell what side of the mass that the particle actually is on.
And my understanding from the quantum tunneling, it's really more it's a non-zero probability that it goes through, and that's why it's such a huge thing. And they do have evidence in the quantum state where it does go through. But it's really more that, right? That it's a non-zero probability more than it is it's gonna go through whether you like it or not. It might type stuff.
Right. Yeah.
So
Goes back to that double slit experiment, but yeah, it may go through the solid mass and it may not. You don't know what side it's actually on.
yeah, radio frequencies is one that I didn't even think about. I guess if you think about it, we're kind of using the technology right now that kind of proves quantum tunneling to a degree, or best exemplifies it, right? Because if you're on Wi-Fi, it's going through the walls, and
Mhm.
in order for it to go through that solid, those particles have to go through the wall, which is a solid. Um, so that, in essence, is a good layman's, I guess, um, example of quantum tunneling. Is I have a solid mass and I have something that's trying to get through it. It normally doesn't get through it in classical physics, but because it's in waveform, it'll penetrate and potentially come out the other end. Um, that's quantum tunneling.
Yeah. In essence, show's over. That's it. No,
That's it. Uh, why is this something that that excites you? I just seen one of your posts, and a lot of your posts are kind of like mine. It's so weird. It's like one like, two likes, three likes, but then you had one just like yesterday, or
Oh man, last Thursday, that's what happened.
yeah, that kind of blew up. It's weird how the algorithm works that way.
Yeah.
Was that about quantum tunneling?
No, it was about graphene having a kind of a state where uh, once they put a charge through it, they were able to put electricity through it, and then heat uh, didn't have to dissipate, or there was no heat that came with the electricity. It was able to dissipate off of the graphene.
Oh, okay. That's a different
So
conversation.
yeah, yeah.
Yeah, yeah. So what excites you about quantum tunneling then? Because you said at the beginning that you're excited about this one. What is it
Yeah.
about
Well, I mean, it's something. It's a field that I kind of work in. I get to see it all the time. Like I said, I get to measure reflections. I get to see how much signal actually gets through a medium. Uh, I work with a lot of connectors, angled connectors, and stuff like that. So, actually have a patent on an angled connector. So, um, I, I was looking at measurement of reflections, and then that was the thing that I was looking at it is the the way that or the definition of quantum tunneling. I'm seeing it right here, you know, in my own measurements.
Uh-huh.
They they say that it's used in SSDs. I'm still trying to wrap my head around that one, but
In what?
I know that in SSDs, the solid
Oh,
state
yeah, solid
drives.
states.
Yeah.
How?
Um, it's something about the information stored in electrons going through the silicon or something like that. The silicon is supposed to be the solid mass. I don't know how that works, but
Yeah, but is the silicon a solid mass? I thought it was just it was more of a fluid than it was a solid mass.
yeah, I mean, that's what I think. I mean, you can't ask me. I'm into the quantum physics, so nothing is solid. So
Well, it's yeah, that's a whole nother crazy world of the quantums. Um,
yeah.
that nothing's really touching, nothing's really, which is weird for the human brain to wrap your head around.
Mhm.
Um, so it's in SSDs and then in nuclear.
Nuclear reactions, and it's also in other nuclear fusion, like the sun. So sunlight coming through glass, glass is a solid mass. You have your sunlight coming through, regardless. Photons getting through a solid mass, which would be how you would envision quantum tunneling as well.
Would that be in glass? I guess that would be my conversation. The question that I don't know because it's a clear, so I guess you do are still getting the UV rays coming through that stuff, and so it's not batshit crazy. This
Mm.
simple concept. It's actually been proven so many times. This idea of the quantum tunneling, and we have so many examples. I didn't realize we had so many examples of quantum tunneling. Um, energy, the way we use our internet, the way we use our cell phones, because they are particles. It is information that is coming through and literally going through solid masses that in a macro scale it would I can't go through a wall.
Not
I've
yet.
tried. Not yet. Yeah, I've tried. So yeah, that's crazy.
Oh man.
That's
Yeah.
crazy.
So
Um, so you get a particle, and that particle turns into a wave. That's where I don't. That's where you lose me with this shit. Is
the crazy thing is, it turns into a wave after it's observed. So
by anything.
um,
And I have to clarify: the observation is anything.
and
And now, when you say observation, because I'm getting this shit confused. and I have to look this up, and we might have to ask the internets here in a little bit, but um, observation and measurement are essentially the same thing. You're measuring how much of it came back, and that is the observation. But when you have a light particle hit the glass, the glass, protons and the particles inside of the glass, the atoms inside of the glass is observing the light hitting it and measuring it via energy or whatever, or heat dissipation or whatever it does, refraction. That is observing it, and it's changing the state of what it is, the
Right.
waveform. Right? Is it the wave function? Is
It's changing the wave function of the object. And actually, if you think about it, you can modify that by the opacity of the glass, by the color of the glass. You can change the actual waveform coming through. So um, small molecules of the glass that changes color or dense or opacity would change the waveform that's actually coming through. Instead of those particles coming through as just particles, they'll come through as waveform. And you can modify the waveform.
what does that do to the energy? Like, does it
Um,
changes the structure of the energy? Because in classical physics, you're taught that you cannot destroy, you cannot create energy. There's conservation of momentum, right? In Newtonian physics, there's a conservation of energy.
mhm.
So how does this not violate that? If you
I don't
know,
think it. I don't think it changes energy by changing the waveform. The only thing you're able to do is to basically change the length of the wave. So um, energy is either gonna go through slower or it's gonna bounce back, but it's not destroyed.
I did hear that it slows down the wave. That so you
Hmm.
have the energy coming in and it just slows it down.
Yeah,
So the obvious question is how? Like it just how does it not just stop it and like what is it about it that slows it down if we know?
to me it's a couple of things. You can say again the opacity of the window or of the glass. If the glass is perfectly clear, then the waveform should have almost a one-to-one transition. If the glass is a little bit cloudy, then that's where it's going to slow down. Or I would think that when the glass is cloudy, it would actually bounce some of the energy back, or bounce some of the wave back. If the glass is, say, you added a pigment to the glass, a color or whatever, the pigment itself then modifies the observation, or it modifies the actual wave waveform, either slows it down or well, it never speeds it up, but yeah, it can slow it down to different wavelengths.
All right. So I'm going through some of the notes that I've written down, and I think this has a little bit to do with what we say. So classical physics. If you
Mhm.
don't have enough energy to climb the hill, you bounce back. Quantum mechanics says the particle is described by the wave function, and the wave doesn't instantly drop to zero at the barrier. It decays inside the barrier and sometimes emerges on the other side.
Right.
So, in other words,
You just
yeah,
get a
this is
less
just
efficient,
what's
you get a less efficient version on the other side. But the fact that you can't tell, any specific particle on one side or the other is where the tunneling part comes from, because you can't tell if that part went through the solid mass, or
yeah,
yeah, if it's on one side or if it's on the other.
that's just bananas. And then particles don't have I've got some notes here, and I want to talk about some of this stuff, and I just want to bounce stuff off of you, and get you to say the words about this stuff. So particles do not have a single well-defined position because that is that is adjacent to the superposition, but not exactly the superposition. I forget
Mhm.
which way it goes. Like one can be this one, but this can't be the other. I forget which way it goes. Um, they have a probability of distribution. If the wave function extends past the barrier, tunneling is possible. Um,
Yeah. The other thing that you put in is you have the possibility of quantum entanglement where you have two particles that match one on one. It could be one on one side, one on the other. That could be observed. So that's the other possibility.
yeah, quantum entanglement is a super weird one for me. I think quantum tunneling is pretty straightforward to a large extent. I don't think there's a ton of argument against, or a ton of valid arguments, anyways, against. I think Penrose has a few things to say about it. Um,
Yeah, he does actually.
Penrose is, and a lot of it, the Penrose just says it's not complete, if I'm not mistaken. Like it's Penrose's complaint about quantum physics in general
Mhm.
is people just say, um, how did he explain it? Like wand waving responses, but there's no real it's not complete. It's not finished. That's why most of the answers with quantum physics is like it's magic. I think Albert Einstein called it spookiness from a distance.
Yeah.
Um, and it's that, and I tend to agree with Penrose more than Einstein because I've read up more on Penrose than I have in with Einstein, especially lately. This argument of we can't disagree, we can't debate whether or not it exists. There's a lot of evidence that it's there. It's just a lot of people, the way they define it is very incomplete and it doesn't make sense. Like
Mhm.
even quantum entanglement, right? Like the idea is I have two particles, and if this one moves, that one moves. Like it's that, but that's not really what's happening. They're not connected. Information is not faster than the speed of light. It's the reality is we just don't know yet. We don't know. This is just what we have observed. And then obviously in the age of TikTok and social media and flat earthers and all that stuff, they add their own mysticism to it. Like it's and the reality is we probably just don't know yet. Um and quantum tunneling is one of those where it's we can't really see it in the macro.
Mhm.
I was thinking about water, like, oh, water kind of does this, but it doesn't. Like that's a very different quantum tunneling because it's not even that shit is just carving its way through a mountain. That's how we have aquifers, right? Like it's up at the top and then it percolates down. But even then, there's gaps in between the sand, and that's why it's able to go down. It's not really going through a mass. It's flowing through the little cracks and um, but water kind of does this. I don't know if it's a good example. It probably isn't. Water, the molecules together. I mean, the tension on it is pretty rough. I mean, you hit it. I'm sure most humans have done a belly flop at the pool, and that shit
It,
hurts.
it's hard to
Uh,
break.
it's pretty difficult to break, but all at the same time, it can change into almost any shape or form, and it'll ruin your house really fucking quick because it'll seep through and all that stuff. So
Yeah.
uh, go.
Yeah, water. I'm not sure if I can. I mean, I use it to explain electrical movement to other electrical engineers, but yeah, I don't see water as an actual
Yeah,
tunneling.
yeah.
Um, Penrose, he doesn't like Copenhagen at all. He rejects his entire his entire philosophy.
Does he really reject his entire uh
He thinks it's lazy.
but you have to agree that it kind of is
I do. That's the thing. I'm on Penrose's side on this one.
because and I think that's his whole point with quantum physics from his perspective is I don't think I've seen a video where he disagrees that it's real or not real. Like I don't think he's seen, but he definitely does say something to that effect of people are super lazy on how they describe it because we don't know yet. We don't have a solid answer. It's there. This is one of those weird situations where we know it exists, similar as antimatter or dark matter, and like we know it's there, but like we're still like,
No,
what is it?
nobody knows. Yeah,
Like
nobody's
it's
seen it.
but we see the effects of it.
Right.
Like for sure we see the effects of it, right? The universe is expanding. Part of it is entropy, but also is like that's a lot of force that's pushing shit out. So like we know it exists, we just don't know what it is. And I think that's Penrose's point is we're just waving that wand and saying this is what it is. It's magic. And like people give explanations that are really not explanations.
True.
It's have you seen that
Metaphysics.
what is metaphysics?
Metaphysics is just people believing in kind of like it's fake physics, ontology, and it's very anti ontology. Things that are not proven, not real.
It's more of a feeling.
Yeah.
Yeah, that's what we did with gravity for a very long time. And
Hmm.
in gravity, if humans, what planet did we make up? Vulcan, the planet Vulcan. I think that was it. Um,
Hmm.
when before we discovered Mercury, I think is what it was. I think my science is correct on this, or my knowledge of the history, anyways. But we didn't understand how Mercury's orbit was working and how it was off a little bit. So we said there's got to be another planet outside, and that's what I'm talking about. Is we didn't know how its orbit was working. So we said there must be another planet there because it worked with every other planet. And at some point, we as if I was there, uh, we as humans, we said, well, no, it's just that's God's correction. It just I don't question it, it's just God's correction. I think Newton said that it's just God correcting the orbit. And I think that's what's happening with quantum physics. We just don't know.
Hmm.
But but we want to try and explain it without really knowing what the fuck is going on.
We're hoping, and I think Penrose would agree on this one, is that we're hoping that some of the future physics will be able to uncover a lot of what we don't know now. But I think that's what you and I are doing. We're trying to uncover it.
Yeah, yeah. You and I single-handedly are going to beat all of the current physicists, and we're going to figure it all out. I think for me
Yeah.
that this is just I don't know if you've ever talked to somebody about physics that asked an innocent question about physics, and then all of a sudden you do the annoying thing, and then you go down a rabbit hole of some wild weird shit, and then they're like, I fucking you lost me at
Yeah.
hello. And I think that's where I want to be with this thing is get those humans to kind of understand a little bit about what we talk about. Because if you listen to any of the videos that has Penrose in it, and it has um I think Neil deGrasse Tyson does okay. He's a pretentious douche, but I think he does okay in explaining it.
Hmm.
But a lot of the physicists just like, I don't know what you said. Like I don't think we're even speaking the same language anymore, and it gets
Yeah.
frustrating at some point.
I think that's something I catch myself doing sometimes. I'll use certain language, certain words, and I'm like, oh, I think I've lost everyone.
Yeah.
I actually had a cognition article that was, I even read it back to myself. I was like, what the heck was I on when when I wrote this?
Uh,
So
so here's one of the Penrose's things. So Penrose's core objections is the measurement problem is not a philosophical nitpick. Penrose takes the measurement problem dead seriously. Standard quantum mechanics has two incompatible rules. smooth deterministic evolution, Schrodinger's equation, sudden
Mhm.
random collapse measurement. Most physics shrug and say, shut up and calculate. Penrose says, no. Two mutually inconsistent dynamical rule means the theory is incomplete. This matters for tunneling because tunneling depends on the wave function being physically real. Measurement collapse is a hand waved. Um, Penrose wants physical mechanism, not an epistemic one, whatever the fuck that means. I've got some notes on Penrose, and that's kind of his argument with all this. It's just bottom line, it's not complete according to Penrose. We don't have enough information, um, which leads to the other shit. This is what happened with string theory. Um,
Yeah.
I'm not a fan of string theory, mostly because of this, because everybody just said, well, there's a multiverse, and because of string theory, I don't believe there's a multiverse. I don't believe there's two different worlds, three, four, five different worlds, all at the same time. I don't
Mhm.
think the math and the science allows for it. But when you have incomplete science, it allows for your brain to wander, like maybe.
Yeah. Yeah. Um, yeah. The whole multi-world theory and interdimension. Um,
Because you believe in that,
it's
right?
yeah. Sort of.
Sort of.
Yeah.
Yeah.
It's the things that I get to see, the way that you can manipulate frequency and frequency and polarity on electrical systems. It makes you kind of look at, okay, is are you able to do this on a grander scale? Is the Earth, can there be more than one Earth that's separated by frequency and polarity, the same way that you're able to modify radio frequency signals?
Break that down really quick. Frequency and polarity.
Yeah. So, radio frequency, or even up to wavelengths. The reason that I say that is because your ears are able to, you have a certain frequency range. I think it's 20 hertz to 20 kilohertz, that you're able to hear. Your eyes they function on a certain range of wavelength. Everything that's beyond those wavelengths you can't see. So if there was, say, another world or something that operates on a different wavelength, or a different frequency, your ears won't be able to pick it up. Your senses won't be able to respond to it.
Is that what you're talking about?
But
Polarity?
it can be polarity as well, because polarity can cancel. If it's tilted, or if it's not the same exact polarity as the Earth. So you have your north and your south poles. If it's a Earth that's tilted the other way, then it cancels out. So it doesn't necessarily mean it doesn't exist. It's just that you're not able to physically see it, and sense it.
How does that come into quantum mechanics though? Is that like where's the tie-in with that?
Into quantum mechanics, it's more so. Well, quantum mechanics is just the existence of uh, basically micro.
Or I'm
Um,
sorry, quantum physics, um, or just the quantum world period.
yeah. So quantum world just they just believe in everything not necessarily being solid. I said they, but everything is not necessarily solid. Everything is made up of subatomic particles, pretty much, that move in different speeds and different densities.
Yeah.
So as the particles get closer and closer, then mass gets more and more solid. So, but everything is not real or not solid.
Yeah, that kind of makes sense for some humans. I was reading up on all of this stuff and learned that the hippies in the 60s and 70s loved this idea because it's very on par with them. Nothing's real. It's all a simulation. It's all make believe. It's all we're just in a machine. We're just
Now I don't believe in the simulation one. Simulation theory is a whole. That's actually a thing now. But yeah,
oh, it's
there's a lot of
huge.
people.
I've seen a
Yeah.
lot of physicists that I respect say dumb shit like this, and for me, it's kind of mind-boggling because a lot of these people are atheist. I don't know that I would consider myself an atheist, but I'm definitely a human that's not religious.
Mhm.
But it's always humorous, right? Because I try and be as objective as I possibly can. But Brian Cox is a physicist that I like to listen to, and Neil deGrasse Tyson every once in a while. Brian Greene is another one, and a lot of these humans, a lot of physicists are not religious humans. They're atheists. They're self-proclaimed atheist, and then they get asked this question: "Hey, what about being in a simulation?" Uh, I'll have to correct myself later on, but I believe I've heard all of them say, "Well, there's enough evidence to suggest that maybe we are in a simulation, and that we're in a machine, and we're basically just essentially in a quote unquote video game." And that gets me to think. I was like, well, if you believe that, then you'd believe in a creator,
Mhm.
because we're just in it. Like it just doesn't clash. It doesn't mesh. Like you can't. To me, anyways, it almost seems like you can't be an atheist and also believe we're in a simulation, because then that would mean that we're created by some sort of creator. And maybe I'm wrong in how I understand their interpretation of a simulation, but to me,
Yeah.
like those two thoughts and those two ideas collide. Like you can't be an atheist and believe you're in a simulation, because the simulation is created by a creator. So
Mhm.
like it just doesn't make sense.
I mean,
um
what language do you think the simulation is written in? Is it Python? It can't be Python.
C plus plus, dude,
C
because
plus
it's
plus.
yeah, because it's a
Oh, it
game.
has to be a little better than scripting. Python is just scripting. So
Yeah, I think a lot of gamers use C plus plus or C sharp.
C
Some of
sharp.
them who use C sharp. Yeah, yeah. I've made a few games, and it's been in C plus plus and some C sharp. Um,
So I actually did put out a small essay about that, about the simulation theory,
uh-huh,
and um, someone asked me about it, so I said, okay, I'll figure out something for this one. But they actually, there's an actual study where they fed an actual simulation system into an AI system. Um, they said the problem with the AI system was that it couldn't really recreate reality. It can get really close. It'll have all the basics, of this simulated world, but there's certain nuances that are in the real world that it just couldn't do, like the wind changing direction, things like that, little small things. So that
and it's almost the important thing, right? It's almost what keeps this Earth from completely going to shit.
Mhm,
It's that balance. It's that perfect balance. And I know we were talking about quantum tunneling, and I think that conversation I'm good with it. If you're good with it, there's probably more that we can talk about, but there's
mhm,
not more that I know. I know very very basic. So, but to that point, if you again in science, I know aggressively medium stuff, but even because I would imagine a simulation would want to perfect everything, want everything to be perfect. And um, we see deserts here on our planet. So you look at the Sahara, and not just the Sahara, fucking the South Pole, Antarctica is
mhm,
essentially a desert. Um, so a desert by definition, but even if we look at what humans believe a desert is, hot, sandy, that type of stuff. We look at the Sahara, and a lot of humans have for a very long time tried or wanted to or pushed for reforestation of the Sahara, not understanding exactly what you talked about right now, the way the wind changes and weather patterns is if the Sahara becomes lush and green, the Amazon becomes a desert.
oh yeah.
Because it all collects there. It interferes with how the wind flows and the weather patterns. Then
Hmm.
now the Amazon essentially becomes the desert. It's such a weird kind of connected thing is the Sahara exists so that the Amazon can flourish, and that's just the way it works. That's just the way it works. I think a simulation would want everything to be perfect, and it
Yeah, it's going to strive for perfectionism, and of course, you bring up that word entropy again. It's not going to be able to simulate entropy at all because there's nothing that can actually stop entropy, and nothing that really speeds it up or slows it down. So it just happens the way it happens. So um, yeah, it's not going to really understand that concept.
or the fucking crazy nuances of space-time curvature,
Oh man.
curved space-time, and how precise that shit is.
So are you saying that we could be in a simulation and just all of a sudden start floating? That would be great.
Yeah,
I would
it'd
love
be
that.
weird. Yeah, there's
Yeah.
just so many nuances. But that's my problem with with string theory. Is string theory is really heavy on the multiverse, and because it's a thing, and it bends, and it's just like, well, I think that's the problem with quantum physics is not enough humans know how to explain it. So because not enough humans know how to explain it, then we're kind of left up to TikTok physicists to tell us how it works.
Mhm.
And unfortunately they just don't know. They just don't know. Not enough information. Um
So I have
yeah.
this question. Do you think math describes reality, or does reality obey math?
Well, that's kind of like which came first, the chicken or the egg?
Yeah.
If you really pay attention, we already know the answer to that, right? Like there was eggs long before there was chickens, so the simple answer would be eggs came before the chicken. So this is that. Like what describes what? Like we didn't have math. We had to create math
Hmm.
to kind of understand it. Um so I think we created math to try and help us out, but I don't think math describes. It helps us simply understand what it is and give us a reason.
Yeah.
Um, but I don't think that math is. I don't know
It's,
how to say this. It's not a natural thing, I guess. If we gave it a number, kind of like time, we gave this time, and right
mhm.
now it's 7:43 p.m. Just because some weirdos a long time ago said it's going to be 7:43 p.m. It's just how we keep track of it. But
Yeah.
if which I doubt, I don't believe so, but if there is another life form in a different planet, they're probably describing the same thing we're looking at, but in a very different math than our math. I don't think it would have to
Yeah.
be our math. What's your thought on it? Or what
So
what go.
so I would say that it might be structural. That we didn't necessarily create it, but more so discover it, and so it was already there. And then we're kind of spending our lives learning how to um, interpret the math, and that the math is what already created the reality, and we're just trying to learn it.
So math created the reality.
Yeah,
Math created gravity.
I think so. And we're discovering the the connection between the math and the gravity.
Okay, you're gonna have to explain that shit to me. How?
Well, just like we have top scientists that are coming up with new formulas. I don't think that they're creating these formulas, but they're kind of understanding the structure that's already there, and trying to figure out exactly how that structure is formed, and then using these formulas
No,
to
I
figure
I
out the
I I
structure.
I got that part 'cause you're essentially saying it's like fire. It's like electricity. We didn't create it, we didn't discover it, we just harnessed it, and we
Hmm.
understood how to work with and manipulate it and do all that stuff. Got that. But what it is where I'm stuck at with your theory or your hypothesis is that math created reality. Like that's the part where you need to break the shit down for me. Um,
Well,
because that is a simulation. That is technically a code.
it could be a code, but no, I don't believe in simulation theory at all. I'm just gonna throw that out there. I don't believe in simulation theory. No, no, no. I'm saying that we are, as humans, are discovering the codes or the math that's already there, that form the structures that we have. That's all I can. That's all I know to say.
Got it.
Yeah.
Got it. I think and I don't want to speak for you, but I guess a better way of saying it is the math exists because the universe exists, and we're just trying to figure out what the math is. Um,
Before we all die.
but I don't. I guess where my hangup is what you're saying is the universe exists because of math, not the other way around. Math exists because of the universe.
Right. Yeah. The universe exists because of math.
You're gonna have to come up with a better fucking explanation of that shit because I'm having a difficult time trying to wrap my head around your thought experiment of how math created gravity and how math. I know you can describe gravity with math,
Hmm.
um, and there's an equation for it. What is it? The inverse equation, if I'm not mistaken, or
Yeah.
I might be mistaken, but I believe it's that. Um, but the universe would exist whether we know the math or not. That's where I'm at.
Hmm. Yeah. I mean,
We're gonna have to
keep
come
thinking.
back to this one
Okay.
because
This is, this is another topic.
well, no, it could be this topic, but have you really thought it out, or were you just kind of just
I'm just thinking that it's the same thing as if you asked, did we discover Earth, or you know was Earth already here and we were born into Earth, or did we come to Earth as another, from another planet or something like that? You can't tell what's happened in the past. So um,
but I think there's enough evidence, and again, we don't know. But with that, we've seen, especially now, enough evidence to suggest that we're most likely interstellar um, beings. In the sense that, let me say this better: the bacteria that we evolved from, if that's the route you want to go with, because I don't know, but if that's the route you want to go with evolution, and this is a science podcast, and science is heavily in favor of evolution versus creation. I don't think they're mutually exclusive. I think you can have both. I don't think you need one and exclude the other. I don't think. Again, I don't know where I'm at with all of that stuff personally, but
I'm
if
the same way with that one.
yeah, like I think you got both. I don't know. Again, I'm not a religious human. I don't necessarily believe in a god or anything, but I don't think I'm an atheist either. I don't know. But at the same time, and I think for a science thing, it is important to qualify where I stand with that stuff, so that people don't believe there's a bias one way or another. Like I'm biased towards evolution or I'm biased towards creation. Like I just don't know. I just don't know where I'm at with that. But I believe that there's somewhat evidence of we colliding with another planet or an asteroid hitting and bringing the life form, and then this almost perfect planet was able to create life, which by the
Right.
way is super difficult to do, incredibly difficult to do. um
in order for us to be in the same form that we are with the same amount of intelligence and everything,
Everything.
like you can't have a bunch of
Sure,
random.
we haven't even found microscopic stuff on different planets or asteroids in our own solar
Right,
system. Like we haven't even found that yet.
right. Yeah, there's no way that it happened by chance. Everybody's
Like
like, well,
it
you have your Big Bang Theory. You have, they call this primordial soup and all that stuff. There's no way that you can form a full being with intelligence out of just mere happenstance.
maybe. I don't know. Like that's where I'm at where like I genuinely don't know.
Yeah.
That is though a big reason why I lean towards there's got to be a some sort of deity. But I'm
Mhm.
also in a position where like I don't know. Like it could be that we're just incredibly lucky or incredibly unfortunate, depending on how you look at life. Um, that we're here by mere chance. Like there is a possibility. It's the same possibility for quantum tunneling to happen is the same possibility for us to be sitting here on this technology talking to each other just
So
because of a
then,
complete fucking accident. Um,
yeah. So you're looking at
I'm not
like,
saying that's what happened. I'm just
uh,
saying it's a non-zero possibility that it was an
you're
accident.
looking at Heisenberg, the uncertainty principle.
Which one is that?
Um, so yeah, Heisenberg is that's a German physicist, of
Yeah,
course.
yeah,
Yeah, his name's Werner Heisenberg. In 1927, uncertainty principle came about.
okay,
States that we cannot know both. It has to do with actual particles. So this actually goes back to the quantum tunneling, but
correct.
says that we cannot know both the position and speed of a particle, such as a photon or electron, with perfect accuracy. The more we nail down the particle's position, the less we know about its speed, and vice versa.
Yeah, which was why it was really difficult to measure the speed of light for a very long time, and I don't think we've perfected it either. Like it's kind of like I think this is how fast it is, and maybe
Hmm.
we do have concrete evidence, and I'm just not aware of it, which is obviously a strong possibility. But there is plenty of videos out there if you go look for them on how difficult it is to measure the speed of light, and it's that is. But I don't think that's the same as not knowing the 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 probability of us being here. I think we have the math on how batshit crazy it is that all of this exists. Which is another reason why I don't discount a magic man in the sky that makes rules and punishes people and does all that. I'm just giving a general example of a deity,
Hmm.
because all of this is batshit crazy. I used to make fun of the Mormons because the Mormons believe in having their own planets or their own kingdoms, and if they're good, they get their own kingdoms, their own planets, or however they call it.
Hmm.
And I don't know if it's true. I don't know if it's not. I tend to believe that it's not true because it seems pretty fucking batshit crazy. But we're also talking about quantum tunneling. Like we're also sitting here about superposition, and we're also sitting here talking about um some really wild shit that has been
Hmm.
proven to be real. Like if I wrote a book, if I went to a different planet and I wrote a book about how quantum tunneling works and all this shit, I'm sure those people would be like, "This guy is fucking stoned. Like this guy licked the fucking magic tree."
Oh,
Because quantum physics sounds batshit crazy.
it does.
Like
Right.
it sounds nuts, dude. It sounds like all the physicists got together and did some shrooms. And this is why I don't discredit like maybe we do get
I mean, there's certain
our own
parts of
kingdoms.
yeah, there's certain parts of quantum physics that again has been proven or is in use, today. especially when you start to go into quantum computing and
For sure.
qubits.
For
So
sure.
they're using theories in quantum physics in
We
order
know
to,
that.
yeah, yeah.
Like, we know that because we see it. Um, we see it. I don't think they've perfected quantum computing, which is why we don't have quantum computers in commercial operations, but that they do have them. They do exist.
Hmm.
Quantum tunneling to a certain degree is why how GPS systems can continue to exist, and I mean there's plenty of evidence of that. Um, the beginnings we don't know, but I think they have found some evidence that this planet, based off of what they've seen in similar planets that did not have the microorganisms to grow what we are today, especially in the conditions that this Earth was at the very beginning stages, super hot, um, basically lava, very little water. So even water we didn't have. Like water is that has been proven, that water is not of this Earth. It came
Mm,
from ice, from space ice, and obviously melted down. Like even that, we've got as a solid foundation to believe that maybe we're not from this planet, which is fucking wild to think about.
right. And I mean, water, the makeup of hydrogen and oxygen, did the Earth have where
Correct.
the oxygen come from?
Correct.
Because the sun itself is a big nuclear
Hydrogen.
reactor,
Yeah. It's
hydrogen nuclear reactor.
yeah.
So
Correct.
I don't know. How was it produced, or how does it multiply?
Well, the water, wouldn't it?
I mean, the water is the makeup of two parts hydrogen, two parts oxygen. But how did the water? I mean, you said it came through as ice. That means that we would have to, in order for it to grow to the level that it has, we would have to have, of course, the hydrogen from the sun coming down through neutrinos, but you'd have to have an equal part oxygen on the Earth in order to have water or to produce it.
Yeah. I'm sure the answer's already there, and we just don't know what the fuck it is.
Hmm.
Because now I need to go study that shit and figure that shit out. Um, because I'm sure the answer is pretty fucking simple. Um, if
It sounds like it. I bet you it's a whole, you know, 3-page article somewhere.
That's where I struggle with all of these conversations is I see a lot of other I watch a lot of science podcasts, a lot of them, different humans, and sometimes their videos are like 40 minutes long, and you and I finished that fucking quantum tunneling conversation, and maybe we just don't know enough, or maybe we just didn't complicate it enough. I don't know which one it is. Like you're talking about quantum tunneling for 2 fucking hours, like it seems batshit crazy. So maybe the answer of where all the water came from, which we don't know
Hmm.
100%. But my understanding is just asteroids and because most of the asteroids are just a lot of ice,
Yeah.
a lot of ice, and I'm sure they already had the the oxygen particles in there, and obviously when it creates steam, when it heats up and it creates steam, separates. Um, I don't know. I don't know. It is a good question though. The fuck did the because we would have had more methane, right, than anything else at that point.
I would
Now I need to
go
go back.
with the lava.
Now I need to go back and study all of this shit.
You have a lot of
Motherfuckers.
phosphorus, some
Yeah.
sulfur.
So a lot of
Yeah.
sulfur. Shit where we couldn't live or exist, and a lot of microorganisms couldn't live or exist.
Can you
Uh,
imagine the smell?
oh yeah. They do say that it was not a very pleasant smell. Venus is the kind of their example because we have sent ships to Venus, um,
Mhm.
and they say is very similar to what Earth would have been like, minus the density because it's super dense there. The atmosphere is bone crushing dense, minus that, but super interesting stuff. We're approaching an hour. I think that's what we did last time. I don't have a
Mhm.
time limit, so I don't want to put a time limit on these. But I
Yeah.
also don't want to say more shit than you want to say. In case you want to save shit for next time.
No, yeah, we can save it for next time. We'll have another topic. Um,
Yeah.
or we can continue this. Well, there's nothing to continue really, but
Yeah, quantum tunneling was not as exciting as I thought it was gonna be. Um, I
oh,
genuinely thought it was gonna be a little bit more it's fascinating. It's just not that interesting. It's just not that exciting. The superposition one kind of excites me, so maybe we'll talk about that, a little bit more about that, and then quantum entanglement,
okay.
because that one's pretty fascinating. Um,
Yeah, I'm still wrapping my head around entanglement. I think I've talked about it a couple times, but like I'm still studying that one.
it's a weird one. So maybe we'll talk about quantum entanglement, quantum, quantum entanglement, superposition. The article that you posted up that a lot of people were interested in. I call bullshit on it, but I think they were saying that it proves on a macro level
Hmm.
um, some of the stuff that we're talking about here. But again, I don't know, and it's because I don't know because I'm too ignorant to know if it's real or not. I'm calling bullshit right now, having zero authority on on the subject, zero authority on the subject. But the article, the post or the article that you placed was pretty fascinating, and it did get some traction. So that fascinates me as well. Like it ruffled a lot of feathers.
Oh
Uh,
man, yeah.
yeah, I seen some of the comments, and some people were
There,
they
there.
were mean. Like some of them were not mean. They were just like, "This is dumb," which is my position, by the way. Is like this seems dumb, but
Yeah,
I
I
haven't seen
mean,
the study.
I read it. It's not it's not something that I'm just pulling out of my ass or anything.
No,
I
for sure,
actually, yeah, I'm
for
like
sure.
I actually wrote down where I got the information
No,
from.
for sure,
So
for sure.
yeah.
But you see, here's the problem with what they call pop science or pop physics.
Hmm.
Is it's no different than any other clickbait article where you get the title and then you read the article and then you're like, oh, okay, like that's not what the title said. That's not what the headline was talking about, or it's really not that big of a thing, or it's not as awesome as you're making it out to be, or you found
Yeah.
it in one data point and you haven't been able to replicate it, but you're still presenting the article because it buys you publicity. And obviously for a lot of these scientists, just having the publicity is enough to get funders excited about your project. So there's a lot of that stuff as well that I'm always super cautious about. Is I understand a lot of these people want to get funding,
Hmm.
so they'll find half of data point and they're like, "Oh shit, we're making progress." And they're like, "Ah, but you're not really making progress." So that's why I'm always like hesitant about those.
So I'm trying to figure out exactly why this one article. I'm like, it was really nothing special about it, but because I kind of post I'll do a study, I'll read something, and then I just kind of post what I see or whatever, and
No,
that's it.
I seen the stuff. I've commented. This was where like, what the fuck did this? I almost didn't even think it was you. I was like, this is not even him.
Yeah, and I don't know what Facebook did. I think their algorithm just like pushed it somewhere.
Weird. Like
Yeah.
it's super weird. I hope you don't mind me doing this. And you see this in our stuff too, in our YouTube videos.
Hmm.
So you did a thing about boiled lettuce. One
Oh yeah.
cognitive hysteria, 7 likes.
So
Uh,
cognitive hysteria is actually mine. That's my
that's
pet
your
there.
article.
Yeah.
Yeah. So this one, which I think is pretty common knowledge about cold welding.
Yeah.
So that one's got 9, and then your dog's got 13, and then all of the sudden, electrons and graphene have done something physicists thought was impossible. Uh, 3.2 thousand likes or reactions.
Yeah.
283 comments, 504 shares. like that one fucking blew up, and then the next one is 10 likes, and then 1, and then 9. Like, it's fucking weird. The algorithm is nuts.
It, yeah,
It's nuts.
just that one post. And I'm like,
Just
why
that
don't
one
you just
post.
push all of them?
So
Just do
weird,
what you
dude.
did for that one.
So weird. We just did a podcast, Isaac and I, on the Gun Channel on Thursday,
Mhm.
and I mean, I think mine's got like 2,000 likes, but the one previous to that is like 50.
Hey, maybe you're onto something because I posted that on Thursday. So
Well, no, we always
maybe
do them on
something happened
Thursdays.
on Thursday.
Yeah, maybe something happened. The universe, it was the chakras and the fucking Mercury retrograde. I'm sure that's what it is.
Yeah, all the three planets lined up.
all the all the
Yeah.
dumb astrology shit just worked out, because I'm sure that's the way it works.
I
um
have no idea because I'm like, well, this one, and I've replied to a couple of the comments, but I
yeah,
keep up. It's growing faster than I could think.
it's crazy. It's bonkers. Yeah. On another page that I run, you know which one it is. There was one video I was like, like, this is it, where we're going through. I think we had like 1.5 million views, and I like 500,000 likes, and it went crazy on Facebook. And then every other post after that, 5 likes, 10 likes, 15 likes. Like, how do you go from a million
Yeah,
likes and reactions to just 5 and 3 and 2? The algorithm's weird, super weird.
yeah.
But at any rate, if you've got nothing and I've got nothing, I think we'll leave this conversation for next week, next Tuesday. We're gonna try and do this every Tuesday, as long as we see fit, I guess, and we enjoy doing this. I'm a big fan of science, just don't know enough, and I hope this helps those of you guys watching a little bit. And if you know a lot more than we do, like, fucking let us know where we
Please.
fucked it up. Let
Yeah.
us know how, and maybe you want to jump on the podcast and have a conversation with us about how we fucked it up, and teach us about where we got it wrong, or what we got right. What we got right. Um, but at any rate, I appreciate you guys. I appreciate all 3 people watching. You didn't bring your 3,000
It'll
likes.
get there eventually. We need
For
to
reals.
have the algorithm smile on us.
For
That's
reals,
all.
for reals, yeah. So I appreciate you guys. Thanks for watching this now, and in the future. See you.
All right.